All right, let's start talking about reflections. So a reflection is a transformation that uses a line like a mirror to reflect a figure. The mirror line is going to be called the line of reflection. So in this image that you can see, line M is our mirror line. And what's happening is P is being reflected. So we're going from P to P prime through this reflection. The reflection in line M maps every point P in the plane to point P prime, so that for each point, one of the following properties is true. If P is not on M, so in other words, if the dot isn't on top of the line, then M is the perpendicular bisector of P to P prime. That's fancy language for saying that M is going to be in the middle of the reflection, okay? The distance from P to M is going to be the same distance as P prime to M, and that's why they've got those two lines there. And if P is not on M, so if the point's not on the line, then P is equal to P prime. Oh, so if P is on M. So you'll notice right there. So if P is on the line, then they're going to be the exact same point. And that's what that is saying. All right. So let's do some reflections. We're going to graph ABC here and its image after we do the reflection off of the line they've indicated. So let's go to A1, 3. Name it A. B is at 5, 2. And C is at 2, 1. Okay. And now we want to reflect it off of the line X equals 3. So right here, here's a dot where X equals 3. Now we want the line of X equals 3. X is going to equal 3 for this entire vertical line. Okay, the Y value is changing, but X stays at 3. All right. And so now what we're going to do is reflect each of those. Now we're going to go, just like they showed in the picture, perpendicular to it. So because that was a vertical line, I'm going to go towards it horizontally. So A goes 1, 2 places towards the line. So to make it the exact same distance, 1, 2 after. And that's where point A prime will be. B will go 1, 2 straight towards it, and 1, 2 after. And that's B prime. C only goes 1 towards the line, so it goes 1 after, and that's where C prime will be. And there is our reflection. Okay, so let's do that again. Get our 3 points. Put on there A, B, C. This time we're going to reflect off of the line Y equals 1. So there's the point on the y-axis where it equals 1, and this is the line Y equals 1. So for A, we're going to go straight towards that line, and we go 1, 2. So 1, 2. And there's A prime. B will go 1, so it goes 1 after. And there's B prime. C is on the line, so it doesn't move. C and C prime are the same point. Okay, and there's that reflection. All right, so now let's reflect off of the line Y equals X. So making this one perpendicular, that's where the trick is. All right, so first f is at 1, -1, 2. And g will be at 1, 2. And the line y equals x. Well, the line y equals x means that they will always be the same. At 0, y would be 0 because y equals x. At 1, they'll be 1. So the line y equals x when x is 0, y is 0. When x is 1, y is 1. And on and on. So it creates this diagonal line right there. So that's our line of reflection. Now, notice how this goes up 1, forward 1. In order to, and it's a perfect diagonal, just going in that direction. So in order for us to draw a line perpendicular to it, it has to be a line that goes down 1, forward 1. And that's how to create these perpendiculars. So as I go from G, I'm going down 1, forward 1. So it went a half, so I'll go a half after. And that's where G prime should be. So then F, down 1, forward 1, down a half, forward a half. So now down a half, forward a half, down 1, forward 1, and that'll become F prime. And there we go. That is our reflection off of y is equal to x. Just make sure that you get that perpendicular diagonal line in order to make your reflection. All right, so coordinate rules for reflection. If A and B is reflected across the x-axis, so now rather than doing it off of lines, we'll just do it off of the axes. So if we reflect it off the axis, notice the only thing that's going to change in the point. Its location along x is going to change the same, is going to stay the same, but y will change from positive to negative, or from negative to positive. The sign will change. If you do it off the y-axis, then notice the y number, b, is going to stay the same, and a, the x coordinate, is going to change signs. If we do it off of the line y is equal to x, notice this change. If the point was AB, the reflected point is going to be BA. So let's even look at that because we just did that. So if G was here at 1, 2, this G is at 2, 1. That F was at -1, 2. This F is at 2, -1. Okay, so that checks out. If we're reflecting off of y equals x, it'll just switch those places. And if we are reflecting across y is equal to -x, not only do the two letters switch place, the x coordinate becomes the y coordinate becomes the x coordinate, but both will change signs in that situation. All right. So let's go ahead and do that reflection off of y is equal to x. So we're going to use f and g from the first example. So that'll be at -1, 2, and 1, 2, f and g. Now the line of reflection, if it is y is equal to -x, then when x is 0, y would just be 0. That's going to stay the same. When x is a positive 1, y would then become -1, 2, -2. And so what we get is a line that's coming down diagonally like this. Okay? Now, we can approach this two ways. We can draw the lines, which I will show. The other way is we can use what they just told us here. Both of those points would be reflected by switching where the numbers are at and then changing the sign. So if f was at the point -1, 2, then f prime should be at -2, +1. Switched places and switched signs. And then G, which was at 1, 2, would then switch to G prime, which would become -2, -1. Switched places, switched signs. And let's go ahead and look at that. So -2, 1, and -2, -1. So f prime, G prime. And then look, if we also do our diagonal perpendicular line, down a half, backwards a half, down 1, down 1.5, backwards 1.5, down 1.5, backwards 1.5. So still perpendicular, still the exact same distance, but we didn't even need to draw the lines if we remember those rules about how it can change. All right, so now let's talk about the reflection postulate, which is pretty simple. A reflection is a rigid motion, meaning the shape stays the same. Okay, and you'll notice they've got all that writing to indicate the angles were the same, the side lengths were the same. It is a rigid motion. Okay, and the composition theorem, which we saw in the last video, shows that if we combine two transformations that are both rigid motions, then the combination of them is itself also a rigid motion. So if I combine two reflections, that will be a rigid motion. If I combine a reflection with a translation, that combination should also be a rigid motion. Which brings us to glide reflection. Glide reflection is a transformation involving the translation followed by a reflection in which every point on P is mapped to a point. Every point P is mapped to a point P is yeah. Haha. It is mapped to a point P double prime by the following steps. First, we translate it. So you'll notice we started with PQ. It translated upwards to P prime, Q prime. And then it did a reflection to become P double prime, Q double prime. Okay, that's what a glide reflection is. We glided, and then we reflected. Okay, glide reflection, a translation followed by a reflection. All right, so let's perform a glide reflection. So we're going to graph ABC using these vertices. So 3, 2, 6, 3, and 7, 1. Okay, first we're going to translate it. Notice that the only thing that really changed in there was it went backwards 12. So I'm going to take each of those points 12 places to the left. All right, so if this is 3, 12 places to the left is going to bring me to -9. If that's at 7, 12 places to the left should bring me to -5. And that one was at 6. So 12 places to the left should be at -6. So A prime, B prime, C prime. All right, and now for the reflection, it says do the reflection off of the x-axis. So the x-axis is going to be my point of reflection. So A prime goes 2 places towards it, 2 places after. And there's A double prime. C prime only goes 1 towards that line, so we'll go 1 after. And there's C double prime. B is going 1, 2, 3 towards the line, 1, 2, 3 after. B double prime. And there is our glide reflection. Finally, let's just talk a little bit about line symmetry. Okay, line symmetry is when the figure can be mapped onto itself by a reflection line. So this line of reflection is called a line of symmetry. Such a line M at the right, so notice we're cutting that butterfly in half, or if we folded that butterfly onto itself, it would match perfectly. So that's a line of reflection. Figures can have more than one line of reflection. So we want to find how many lines of symmetry each of these hexagons have. So we got a line of reflection going like that. So there's one. We could do another one coming down like that. There's 2. Diagonals wouldn't work really, because if we tried to reflect across a diagonal, that wasn't drawn very well. Let's try that again. So if I try to do a reflection, notice that this point right here, as it comes up, it would be off. So it wouldn't map perfectly back onto the line. So those are my only 2 lines of reflection. Here, first, we could have vertex to vertex and just do all of our vertices. So we've got 3 just from that. But then we could also do the middle of the sides to the middle of the sides. So 1, 2, 3. So altogether that had 6 lines of symmetry. Really only see 1 here. So this one has 1 line of symmetry. Okay, I hope this helps. Good luck.